My name is Jay Swaminathan, and I'm going to be taking you through this for the next 1 hour. And this is actually a little longer session, which is about it's a 90-minute to a 2-hour session, which I'm going to kind of compress into 1 hour. So please bear with me as if I skip over some parts. But if you have questions, feel free to use the Q&A tab in the live meeting to ask me questions, because I'm told that other than me, everyone else on this call is being muted. So yeah, if you have issues with seeing the presentation or me not being audible, again, please use the Q&A tab to let me know that, so that I know and I can speak up or something like that. Okay, so thank you once again for attending this session. And I was stepped in as a substitute speaker for this session, and I've taken a few liberties in slightly modifying the presentation from just looking at assessing an application to also, because assessing an application in my purview is probably a little easier to do, and you really don't need a 1-hour session on it. But I also thought that would be interesting is also to talk a little bit about once you've made an assessment and identified an application, what is it that you will need to do in order to migrate it next, right? So that's why I've kind of increased the scope of this presentation to also include the guidance from an architecture perspective on migrating applications to Windows Azure. So let's go through this. So like I said, so the first part of the session is going to be about the value of Windows Azure as a cloud computing platform, and also about how to make an assessment to choose which application is suitable for running on Windows Azure as a platform. And then the second part of this session would probably delve into the technical considerations that you will have to consider in order to move any application onto Windows Azure. So, broadly, what is it that's forcing IT departments within organizations to look at cloud computing, right? So there are multiple changes that are happening simultaneously. One is obviously the economic changes or challenges that we have been through, where most of the IT departments have seen a reduction in operating and capital expenditures, and they are expected to do more with less, or in fact, deliver the same level of services, if not more, using while continuing to consume lesser resources, right? So that is obviously the economic challenges which is posting this. Then there is the technology changes, which so things like Windows Azure and the platform, and also other third-party applications which are making it capable for applications to run on a cloud, right? And then obviously there is the business changes, in order to stay active, competitive, in order to reach out to a larger geographically spread out organization, and things like that. So like I said, IT organizations obviously feel a lot of pressure, right, in terms of being more efficient, being more available, enable business drivers, meet challenging budgets. And so these are the pressures that are put on IT. And obviously cloud is one of the technologies that IT can leverage in order to meet these challenges that they are facing. Broadly, what are the benefits of moving to Windows Azure, right? So one is that obviously, it gives you the advantage of moving to a operating expenses model, moving away from a capital expenses model to an operating expenses model, which essentially means that you don't spend money up front on hardware for servers, storage, networking, and rest of it. Then there's the other thing about it abstracts out the maintenance of these physical infrastructure, right? So you don't have to have the headache of managing all of these physical infrastructures anymore. All of that is outsourced to the service provider. Then the third point is around rapid deployment, right? So traditionally, I've heard the companies complain that they need at least anywhere from 2 weeks to 2 months in order to roll out a new service, because that's the amount of time it takes for them to procure the required hardware, make it operational, and all of that, and launch the service, right? So here with a cloud enabler like Windows Azure, you can drastically reduce that period of 2 weeks to maybe 2 hours or even less, right? So it takes about 10 minutes to provision a server on Windows Azure. So it takes less than half an hour for you to provision it and deploy your application and make it go live, right? So that's the rapid ease of use that a platform like Windows Azure brings in. While abstracting out the headache of having to manage the traditional hardware components that you're used to, which also frees up the time of an IT person to concentrate on more value-add stuff rather than doing the mundane tasks. So like I said, so Windows Azure is very, very compelling in both business and technical audiences, and it is obviously a leading edge tool, and we are in the process of adding newer features onto Windows Azure on a 3-month cycle. So as opposed to the traditional Microsoft products where we have a 3-year cycle during which we add new features, here in our cloud platform of Windows Azure, we are having the period shortened to be about 3 months. So we have new features added every 3 months, and that's a really rapid development cycle that we have. So like I said, it's really not very different. It's just a lot more for you. And the great thing is that, you don't have to do anything really new. So if your existing applications which are on .NET and SQL Server, with very minimal changes can move on to Windows Azure, right? So the minimal changes is to make the application more a cloud-ready application rather than having it be as a on-premise application where it is in a stateful environment, move it to a stateless environment and run it on the cloud. So I will talk a little more in detail about what I mean by stateless environment as we go through this presentation in some of the following slides. Right? So obviously Windows Azure is a great platform, and but what kind of applications make sense to move on to the cloud, right? So this is obviously the biggest question, and this is one of the questions that you need to ask before you start out on this journey of cloud or Windows Azure. And so some of the aspects to look at is there are both the business aspects as well as technical aspects, right? So there are some of the typical questions which are listed out on the slide, like what applications are worth moving to the cloud, which applications need to be redesigned, how much effort will it need to redesign an application, are there areas inside my organization where I can utilize this technology. So essentially what happens is, so obviously you will take a look at the entire IT landscape of your organization, and you can probably put the various applications that you have running across your IT landscape based on these business and technical considerations into things that will probably continue to remain on-premise for various reasons. These reasons could be things like regulatory requirements, your own business continuity requirements, or data sensitivity, right? Or you look at applications which can move on to the cloud. And obviously, again, within these applications which can move on to the cloud, because you're probably going to have to classify them into two, where you're looking at certain applications which can be moved on to the cloud with very minimal changes, right? So these are probably the quick wins, and these applications can be transitioned to cloud with minimal changes. And then there are going to be some applications which are really old and they're not really built as a scalable application to be run on the cloud, and those are probably applications which will require a little more effort in order to move it to the cloud. So those are probably a little long term that you look at. And so the other considerations that you will want to look at is things like the workload patterns for these applications. What is the workload patterns? Do they make sense to move it to the cloud? Are the applications having burstiness, whether it's predictable or unpredictable, or are they having a lot of growth potential because of which you may have limitations to scale the application within your own data center and you would like to leverage the cloud? Or are the applications an on and off kind of workload where, the application is only used for a small period of time and it does not make sense to provision hardware for that within your own data center, and it's easier to leverage the cloud resources just for that particular period of time, right? So those are some of the workload patterns you may have to consider. Then there is the user location, so you may want to look at if your users to the applications spread out globally, how do you reach out to them? How do you make sure that there is no latency effects and things like that so that they have the same level of service irrespective of where they are logging in from, right? So given all of this, then you will probably identify the applications, and once you identify the applications, there are different kinds of scenarios in how you can migrate it to Windows Azure, right? So some of the scenarios are things like, a data center extension, where you're essentially moving a certain amount of applications out of your data center because one, either you may have reached capacity in your data center, or two, you may not want to be adding additional hardware into your data center and want to leverage the cloud. So you're deploying some of the newer applications on a cloud directly. Or you could look at scenarios where what we call as application extension, or hybrid applications, where you have the application run in-house in your data center, and in case or in times of really burstiness where you need excess capacity, then you leverage the cloud for that excess capacity alone, right? So the application will run on-premise for most of the time, and then in terms of the peak load, it will leverage the cloud. Or it could also be a case where you can run the application on the cloud, but due to data sensitivity issues, continue to keep the data on-premise. So essentially in your three-tier architecture, you keep the database tier on-premise and the web and app tier on the cloud. So that's also one possibility that you could look at. Again, that has certain considerations that you will have to look into from a technical perspective in order to implement a scenario like that. And the other option is also obviously for storage and archival, right? So you could leverage a platform like Windows Azure for storage and archival as well. So the assessment process, right? So obviously, like I said, so you would go through the candidate applications that you have, and you will assess the benefit cases, whether it makes sense to move it to the cloud, and then you do a migration suitability both from a business and a technical perspective, and then you build a migration plan based on that, right? So what we have here from an assessment migration is that we have a migration assessment tool, right? This is a freely downloadable tool from the web, right? You can download it and run it, and so it asks you for a key set of questions, and it looks at things like the technology used, integration with third-party applications, or integration with on-premise applications, the security authentications that you may do, how much scalability are you looking for, what kind of service levels do you need, right? The data considerations, latency, provisions, and all of that, right? So it's got about 40 questions, and it's divided into these 14 main areas, right, which straddle across both business and technical. So once you go through this assessment tool for your application, it prints out a pretty nice report where it tells you the suitability of migrating your application to Windows Azure, and it will tell you which are the areas where you may need to look at reworking the application in order to make it suitable for Windows Azure. Right, so it's a pretty good tool, and I don't want to talk too much about the tool. It's a GUI-based tool. It's pretty easy to use, and I would suggest that you guys just download the tool, and by running, try taking a sample application and running it, and it will generate the report, which will tell you what will it take to move that application onto the cloud. Right. So once you have run your application on the cloud, right, then what happens, right? So there are certain considerations that you need to look at from a technical perspective in order to run the application in a seamless manner so that the end user experience remains the same as what the end user is used to with the on-premise deployment, right? So the fact that the application is now running on a cloud service and not on-premise needs to be transparent to the end user, so to speak, right? So from that perspective, there are certain technical considerations that we need to look at in order to make sure that transparency happens. So what is Windows Azure? Right? So within Windows Azure, we provide for compute and storage on a very, very massive scale, and then we provide for App Fabric, which is the service bus and the access control mechanism through which we integrate the application running on Azure with other applications which may run elsewhere, on-premise or on other clouds, right? And obviously, we provide for the developer SDK. So what we have really done is we've managed to keep the developer experience a constant, right? So if you have developers who have developed applications using the traditional .NET in a Visual Studio environment, there are very little changes in the way they build applications. To a large extent, they will continue to build applications the way they have been doing it traditionally, right? Well, it's only the deployment that has changed. So when I say it's the deployment that has changed, what I mean by that is that, we have the way we manage the instances on Windows Azure is very different from the way you would manage an instance on-premise, right? So there is currently no admin control that we provide to the end users, right? So all of the control is managed by Microsoft, and it is mostly automated, right? And then there is things like volatility of how we manage the state, right? So there are different types of roles that we offer, right? Currently, we offer worker roles and web roles, and in the future, we will be introducing VM roles as well. So worker roles are essentially your web front-end roles. Sorry, web roles are essentially your web front-end roles that, they are the landing page for the users who are accessing the application, right? And then you have worker roles, which is essentially to run codes and logic. So if you have a certain amount of logic that needs to be performed, the worker role will take care of it. And then obviously we have SQL Azure, which takes care of the database requirement. So that's a relational database as a service that we provide similar to SQL Server that you've been used to. And we do we do the management of it. So we abstract out the regular DBA kind of requirements that you may have been doing traditionally, and Microsoft takes care of that for you on SQL Azure. While we continue to give you capability to do it if you wish to do so. So the same tools that you have been using to manage a SQL Server can be used to manage your SQL Azure database as well. And like I said, so instances, they are essentially the roles run in individual instances. And we have hundreds of these instances that we run and manage simultaneously, actually even thousands of instances. The VM role that we have as to come is essentially offering a Windows Server 2008 image. So it's essentially a standard Windows Server image, 2008 server image on which you can load any abstract of your preference, right? So if you have a certain application which is running currently on-premise, you can take a snapshot of it and bring the VHD onto Azure and deploy the application on Azure directly, right? So here, the main difference between the VM role and the web role worker role is that web role worker role are meant for cloud-based applications where, they can leverage the automation and the cloud capability that Azure provides to you. Whereas in the VM roles, you still run your application traditionally, and you would not get to exploit all of the benefits that the cloud provides to you from a high availability, from elasticity perspective. Right. Again, so like I said, the roles are dynamic in nature, right? So we obviously will move the app from one instance to another instance for issues like patching or a failure, or for some reason we need to move it from one side of the data center to another. So, which is essentially why we need to have the role run in a stateless environment. So what happens is when we move the role from one physical server to another physical server instance, all of the data which may be stored locally will get lost, right? So we encourage people to use the centralized data so that gives us the capability to manage your application and move your application. And this is also useful when you are looking at scalability of your application. So if you are running, let's say, 10 instances of an application and you want to scale it to 20 instances because of a peak in the workload, right? Unless you are using the centralized storage, some of the information which may be stored locally will not get transferred across the 10 new instances, right? So for this reason, we recommend that you do not save any information locally and rather use the centralized storage, and that way you will be able to take advantage of the cloud capability of the application, right? So the other thing is about, like I said, currently we don't provide for admin privileges, we don't provide for free setup or configuration, and these two will be available when we launch the VM roles in November timeframe. From a networking perspective, again, there is a tendency with the developers to actually hard code IP addresses and things like that, port addresses and stuff. And again, here that's actually a very bad programming practice. And in a dynamic environment, it is not possible for us to support things like that, right? So we need to be able to have this dynamic networking capability, and your applications should not have any of these things hard-coded in them in order to be able to run efficiently on the cloud. Right, so from a summary perspective, like I said, we recommend that you look at making the application more stateless, since the local state is a lot more volatile than what it used to be, right? So traditionally, you know which is the server on which the application is running, and you go into the data center, you know which particular application is running on which server, and that gives you a certain amount of convenience in configuring it and stuff like that. And also, you tend to write the logs and diagnostic information and things like that onto the local disk of that server, right? But when you're moving to the cloud, you need to get rid of that notion that, there is a single particular server on which the application is running, and I can utilize these resources that exist on the server, because your application will now get deployed on any of our thousands of servers, right? So we need to have the capability to do that, and we need to have the capability to scale up or scale down your application as per the workload requirements. So in order to do that, you need to understand that the local state is more volatile, and you need to move to a stateless environment in your application as well. The other thing is about latency and timeouts. So obviously, this is another area of concern when you move to a cloud. So traditionally, your application is running in your on-premise data center, and most of your users are probably accessing it from a local area network, which means that there is very minimal latency that they would experience, right? But now that they are running it off the cloud, now that you're running the application off the cloud, that probably means that all of the requests are now going to be routed in through the internet, right? So the requests are going to come through the internet, and also the data, like I said, or the files, like I said, are not going to be stored in the local hard disk, but in a centralized storage. So there is going to be an additional data and actually, additional latency, and actually retrieving the data from a centralized storage rather than from the local disk, right? So these are considerations that you have to keep in mind when you are looking at migrating an application onto the cloud, right? So the timeout intervals will have to definitely be reassessed. And the other thing is about polling and how frequently do you poll, right? So obviously there is a cost associated with something like that, right? So there's a huge difference between polling every 100 milliseconds, which you may be doing in your traditional on-premise application, to polling every 1 second, right? Why that matters is because, one, you are essentially going to do 1/10 of an amount of polls, which is a lot more efficient. Two, it becomes even more efficient when you have a lot more instances of the application doing it, right? So on-premise, you may have one or two instances of your application running, which is polling every 100 milliseconds. But now on the cloud, assume that you have two instances of your application, you have 20 instances of the application. If 20 instances of the application are polling every 100 milliseconds, that in itself can, constitute a lot of latency and timeouts. So it is probably a better programming practice to reconsider how often do you want to poll, given that now it's on an elastic cloud environment. Right, and this is, like I said, very critical for customer-facing applications, for applications where you're doing live and synchronous messaging and querying. So that's clearly an area for you to revisit as you look at migrating an application latency and timeouts. This is one of the critical factors, and it is even more critical if you're looking at these hybrid scenario that I talked about, where you may have the app and web tier of your application reside on the cloud and the database tier reside on-premise, right? So here the latency and timeouts may have a larger effect than if you have the entire app with the database tier also on the cloud, right? So if you are doing the hybrid requirement, then you need to spend a lot more time in figuring out the latency and timeout issues that may crop up because of this hybrid design, right? And you may also want to revisit the stackiness that your application has between the app tier and the database tier, which is something you may want to revisit. And obviously, you'll have to look at workarounds, which is things like probably caching some of the data or sharding some of the data and things like that. Those are some of the things I'll talk about subsequently later in this presentation as well. So transactions and bandwidth. So this is something new which probably, as IT people, you've never thought of, because like I said, traditionally you're running your application on-premise and all of your users are probably coming into the LAN. So there is really no cost associated with the amount of bandwidth being consumed and the amount of transactions being performed, right? But now that you're moving the application onto the cloud and the entire usage is through the internet, right? So the bandwidth is being charged for, and the transactions are being charged for, right? So this is another consideration that you will have to take into account when you are planning to migrate your application onto the cloud. So, like I said, so you will have to look at, pay attention to make sure that the application performance remains the same, and also look at the cost of switching from disk access to the Azure centralized storage, and also the cost of doing authentication through the access control in the app fabric, and also using the service bus to integrate with third parties, right? So these are some of the transaction and bandwidth considerations that you'll have to take into account when you run your service from the cloud. Right, so one of the possible choices for mitigating some of these transaction and bandwidth costs is to actually use batches rather than single queries, right? It's a lot more efficient to do it this way rather than the traditional way of associating a role with a single query and processing it sequentially. So this is a lot more efficient, and it also helps you do a lot more in parallel. And as you grow the number of instances, it is also easier to manage the query when it is in a batch mode rather than in a serial mode. The other option is also to use meta-message parsing, where you again club multiple queues into one, and then you distribute once they reach the worker role, then based on the type of message, they are then again redistributed. So, like I said, so transactions and bandwidth, it's a new area, something that traditionally IT organizations haven't given consideration to because they have not had a cost associated with it for applications being run on-premise, but the users also accessing it through the LAN. Another area to look at is the authentication and authorization, right? So authentication is to verify that the user is who he says, right? And authorization is essentially based on whether he is allowed to do something that he's trying to do or not, right? So there's obviously recommend for role-based authentication, which means that you give privileges to roles rather than individuals, and that is a lot easier to manage rather than giving privileges directly to individuals. So here, when you're running the application on Windows Azure, there is there's not a huge difference in the way you have been using authorization traditionally. So if you're using .NET Framework and membership roles to provide providers, then that remains the same. You could use Windows Live ID or OpenID as well for authentication, or you could also integrate it with your Active Directory on-premise. So if you have an federated Active Directory version 2 on-premise, then you could have the application running on the cloud, authenticate users signing onto the application through the exchange of claims tokens. So essentially, you don't have to have them authenticate themselves separately to access the application running on the cloud. So we provide for a single sign-on mechanism, and through the exchange of claims tokens between the local Active Directory server and the cloud application, we can authenticate the users. This is an example of how we do that. So essentially what we do is we may have all of these different apps, and we have an App Fabric access control API through which you would access your local Active Directory server and authenticate the user request. Make sure that he's a valid user and the roles are he's authorized for the role that he's trying to access. So here again, there is no great difference between what you have been doing here, typically for on-premise, except that here you're taking the application onto the cloud, and the authorization is happening between the Active Directory, which is on-premise, and the application on the cloud. Other than that, otherwise it's the same thing. So local state, like I said, Windows Azure instances are highly dynamic, right? So they are a very volatile state, and the state changes in one instance. If the state changes in one instance of the application, that will not get reflected across all the other instances. So, for instance, if you are, managing the session state in memory, and if the user logs back in and is directed to one of the other instances of the application, the in-memory session state saved in the other instance will not be retrieved here. That will be lost, and you will have to go start from scratch. So in that case, what we would recommend is to use an outproc session state management, where you would use the Azure table storage, or you would use the SQL Azure database to actually manage the session state, so that the session state can be saved across all the instances, and irrespective of which instance the load balancer directs the request back to, they will be able to continue with the same session. Right? So like I said, so if there is temporary data which is only meant for a single instance, that can remain on the local hard disk, and even if it is lost, it probably doesn't make a huge impact on the application and the service being provided by the application. But all other data needs to be moved to the external storage, which is either the Azure storage that I'll talk about, or the SQL Azure database. So on Windows Azure, we have multiple forms of centralized storage. One is the SQL Azure database, which is an extension of the SQL Server to the cloud, which I've already talked about. The other is the Windows Azure storage, where we offer multiple different types of storage. So we have blobs, which are large blocks of storage, which can be used for both public and private, right? So you could host your URLs, and you could also put stuff which is public, and this is essentially used for storing content like files which are used randomly, or you could use it to store large serial blocks of content like audio files, video files, and things like that. And you could also use the blobs along with our CDN, which is the Content Delivery Network, which is similar to an Akamai kind of system. So if you have a high-traffic website, the CDN will copy the information from the blob onto our edge network server, so that you have a low latency user experience, where we are reaching out to the end user from a edge network server, which is much closer to him, rather than him coming and hitting the application server. It's probably a hop or two away, right? Then you have the private blobs, which are for storing your code and they are secure to your account and they have a lot of security associated with them. There are, like I said, there are block blobs and there are page blobs. Page blobs are more like your NTFS file system tables. They are page tables where you can actually have random access. The block blobs are more for serial access. And we also give what we call as X-Drive, which is an API to which you can mount a page blob as a drive on the instance. Right? So the application can then write to that drive, which will in turn write onto the Azure blob, right? So again, here it can be read by multiple instances, but the write functionality will be only on one instance, right? So the other Azure storage options are queues. Queues are essentially meant for message parsing between the various instances, and then tables. Tables are essentially similar to your database tables, except that here we do not support for the relational capabilities that a standard relational database provides for. So these are non-relational tables, but we still provide for things like indexing, and you can have primary keys, secondary keys, and things like that. So if you have a storage requirement where you're not using for the relational capabilities, foreign keys, and you don't need to utilize the functionality like reporting services, analytic services that a traditional relational database provides you, then you can use this tables functionality to meet the same requirement as a SQL Azure, except that, like I said, without the relational and the other functionalities that SQL Azure provides. So like I said, the local state is very, very volatile, so we recommend that all of the storage, which is essential, and the session state management be done out doc, and you only use the local state for storing any kind of temporary data. The next aspect is about data sensitivity, right? So here, there is obviously a lot of concern about kind of data that you're storing, how is it going to be stored in a cloud, who takes care of it, what if somebody hacks into my application and hacks into my data, right? So again, here this is a concern that as an IT person you will have to look at, right? So is the data of the sensitive type where you're holding information like personal identification information or information regarding salary or confidential information, right? Do you want to put that kind of information on a cloud, or would you rather keep that kind of information on-premise? That's a call for the business or the organization to take before they decide to move something like that onto the cloud. The other one is, like I said, about security concerns, right? Is Microsoft putting my data on Microsoft as secure as putting it on-premise? In most cases, I would say that putting it on our data centers are probably a lot more secure because we probably have a lot more security around the way we protect our data than what you may be traditionally doing on-premise, right? So we currently run our Generation 4 data centers. We run Windows Azure out of our Generation 4 data centers, which are ISO 27001 and SAP 70 Type 2 certified. And we have a lot of white papers on the kind of security that we have around our data centers, and we follow this concept of depends in depth, where we have multiple layers of security, whether it is from a networking perspective, whether it's from the operating system or in the virtualization layer or on the app layer. So there's multiple layers of security that we have in place. And obviously, there's also Microsoft's credibility, which is at stake here. So anybody, if someone were to actually hack into system, it is also Microsoft's credibility that is at stake here. So we do have audits from periodic time periods, and yeah, so if you have certain security guidelines, we can look at it, and we can also tell you what are the guidelines that we need. And obviously, I talked about the ISO and the SAP certification. We are also in the process of getting certifications with regards to other compliances like PCI, HIPAA, etc. And we hold ourselves to much higher standards than what these industry standard compliances require, right? But one of the things that you need to be aware of is that if there is an weakness in the application which can be exploited on-premise, that will continue to be an issue when we move it on cloud. So irrespective of whether your application is running on the cloud or running on-premise, you have to make sure that the application is secure enough and there are no weaknesses which can be exploited. And finally, our coding methods for securing, yes, you could find a lot of information on how to secure applications on Azure through a lot of blogs written by Microsoft employees on forums like MSC, and so there is a lot of information which is available on these forums where we've talked about how to make your application more secure, right, on the cloud and things like that. So that's another resource that you may want to consider. Okay, so there's a question with from Kiran, which is that are there any case studies that say data is not secure on-premise? I'm not sure if there are any cases to say that data is not secure on-premise, but what I meant was, like I talked about, our data centers do have standards, industry standards that we adhere to, right? And these are besides Microsoft's own standards, right? So these are things like ISO 27001, SAS 70 Type 2, which are essentially data center guidelines, right? Securing the data center. These are guidelines for securing the data center, right? And not every organization would go and do an audit of that sort. It's a pretty long, drawn-out, exercise to do an audit of this sort, and not all organizations would do that. So does that mean, so they're obviously not certified, but does that mean that they are compromised? Not really, right? So again, that's a call. But there may be some weaknesses which exist which we are not aware of, right? So like I said, we also do things like we engage these ethical hackers, so to speak, right, in order to ask them to try to break into our things. So that is also available in one of the white papers where we have had 3 different agencies who have tried to break into Windows Azure and their experiences and how they've not been able to do that, right? Again, does that mean that somebody else tomorrow cannot do it? No. But at least that is some kind of certification where we have had 3 of these companies who are experts in that domain to from a security perspective to come and audit our setup and give us a certification saying that yes, you are meeting these norms and you are adhering to these regulations. And a traditional vendor may not choose to do it, and it may not be necessary for them to do it, right, either. But in some cases they do it, especially in certain organizations where they're dealing with third-party data or they have regulatory compliances because of which they need to do it. Yes, they go through the process of doing something like that. But again, that's something that's a choice that the organization chooses whether to do or not. So another couple of ways to handle data sensitivity is one is segmentation of data, right? So let's say if you're running a web-based e-commerce website and you want to run this on Azure, but you want to keep some of the information behind the firewall. So essentially you're segmenting your database into 2 and you're just holding the shipping information on Azure while the purchase database remains on-premise and there's access to a secure service bus, right? So this segmentation is one option. So similarly, if you have, let's say, a HR application where you are accessing employee information, but then you choose to, let's say, you want to do a performance appraisal portion of a larger HR application on Azure, right? So, but you choose to keep the HR database, which contains confidential information about the employee, probably social security number, his salary details, etc., on premise, and you may just cache the employee ID and his performance grade or just a performance report on the cloud, right? So that way you are not exposing the sensitive data onto the cloud, right? So that is one way of doing it, by segmenting. The other way is also by sharding, so that you are essentially splitting a single large database into multiple smaller databases. And again here, so you may choose to keep it all on the cloud, or you may again keep it on-premise, split it between keeping it on-premise and keeping it on the cloud. So that's another option. So the first option was segmenting, the second option is sharding. And obviously the other option is to encryption, right? So you can go in for encrypting your data. Obviously there is a certain cost associated with encryption. And sorry, there's a question which is, for security, can you use digital certificates in Azure? Yes, you can use digital certificates on Azure. So encryption, yeah, like I said, there's an additional cost involved with encryption. And again, as far as encryption goes, you need to take a call on whether you want to encrypt the data while it is in transit or while it is resident, or in both cases, right? So these are some of the concerns that you will have with regards to encryption, and you'll have to take a call on how you want to encrypt it. And like I said, so this is an additional cost which may also result in a performance hit because of the time taken to time and the latency in encrypting and decrypting the data. So ideally, right, so from a data perspective, I would say that you would want to look at a mix of all of the ways I talked about, right, whether it's segmenting, sharding, encryption. So it's not that you would want to use just one of these, but you probably want to use a mix of all three to get the appropriate level of security that you're looking for in migrating to Windows Azure. So like I said, there is no huge additional concerns with regards to data security. So whatever weaknesses that you have on-premise will probably exist on the cloud as well. But given that we do a much better job at audits and regulatory compliances, in a lot of cases you may find that the cloud data center is slightly more secure than your on-premise data center, right? And there is the other combination of data security measures which you can also take in addition to in addition to what is available to make your get your level of comfort from the data access perspective. Finally, there's a question which is, are there any standard editions of Azure which come free to start with, like Express editions? Okay. Yeah. So we do have an introductory offer, so that we say that, as a part of the introductory offer, there is a certain amount of hours that you get free of cost every month. And information about that is available on the website. If you go to the pricing section of Windows Azure website, you will find information with regards to what is available. And if you have Visual Studio and if you are an MSDN Premium subscriber, then there is a lot more that we offer in terms of free stuff. So essentially, if you have a MSDN Premium subscription, you get to run a single application pretty much free of cost. And you can also have an instance of the SQL Azure database for free of cost. So that's one of the options. Even otherwise, actually, if you look at it from a pricing perspective, you would find that it is not very highly priced for somebody to actually go out and test something. So you can go out and do a POC or a pilot at a very, very small cost. So unlike your traditional, on-premise rollout, where if you want to roll out a new service, there is a huge upfront expenditure in terms of the cost incurred in procuring hardware and software licenses, right, in order to roll out the service. Here you're probably looking at a fraction of that cost to roll out a service and keep it up and running for an entire year, right? So there are some free stuff that comes with Azure, but you will also look at if you look at it, we have a TCO comparison tool which gives you a comparison between running something on-premise and running the same thing on Azure. So it's a pretty good tool. Again, it's available on the Windows Azure website. I would also encourage you to go through the TCO tool, and it will give you an idea of the cost comparison between what it takes to run on-premise to what it takes to run on the cloud. Finally, just to summarize, so like I said, we talked about the value of Windows Azure as a platform. So obviously, I think most of you have tuned into this session because you understand that there is, that cloud does provide you with a lot of benefits, and that is something that you would like to exploit for your organization. And I hope that I have given you sufficient information about Windows Azure and capabilities of Windows Azure and how you would go about doing assessment and migrating an application onto Windows Azure. So like I mentioned, there is the migration assessment tool which is available on the website, which you could download and run, and that gives you a pretty comprehensive report on what is the effort involved in taking your existing application onto Windows Azure. And then we discussed about the different considerations that you have to take into account before migrating applications. These are things like the dynamic environment, the latency and timeout issues, the transaction and bandwidth costs, and finally the data security and sensitivity as well. Right? So I'm sorry if I kind of ran through the presentation a little too fast, but like I said, this is a 90-minute presentation, and I was trying to cramp it into 60 minutes. And if you have any questions, please feel free to ask me the questions. And and my email address is up there. So if you have questions after this, you can also shoot me an email, and I'll be more than happy to respond. So I do see some questions which I'll take right now. One of the first questions: are there any SAP customers who have moved their SAP applications to Azure? So SAP is one of the partners that we are working with. So currently, we do not provide support for third-party applications like SAP or Oracle on the cloud, on Windows Azure specifically, right? So we cannot host an instance of SAP on Windows Azure currently, but that is something that we are working with SAP on. Having said that, yes, but we don't host SAP directly, but we have had customers who have put out portals which integrate with their on-premise SAP, especially in the manufacturing space. We've had a lot of customers who have put out portals which integrate with SAP on-premise, and these portals are accessed by their vendors, distributors, etc., who are entities, third-party entities to their organization, and they didn't want to expose their on-premise SAP, which is behind a firewall, directly to these third-party vendors. So instead, they put out this portal on Azure, and all the vendors or distributors hit this portal, and they then hit SAP through a secure connectivity link from the portal on Azure to SAP on-premise. So that's the model that we have currently, but we don't have support for SAP right now. Second question is, can we integrate Azure with Velocity for caching purposes when we migrate ASP.NET? No. So currently, Velocity is only supported on Windows Server, but that is something that we will have as part of App Fabric. So like I said, we currently have access control and the service bus, which are the two components of the App Fabric right now. and we will have a caching component which will be similar to Velocity, which will be available shortly. Right? So that is something that we do have in the pipeline. Questions I have on the so I think we have about 5 more minutes. So if there are any more questions, please feel free to shoot it off through the Q&A tab, and then I will just allow us to just wrap up the session. So like I said, I think we will have a version of this PowerPoint presentation available for you guys to download after this, and I guess you will get an email on how to do that. If we do have you guys registered for the session, we should be able to tell you how to do that. Post the session, you should be receiving information on that as well. Okay, so yeah, one more question. Okay, there's a question about integrating on-premise SAP and on-demand SAP applications on Azure. Yes, like I said, yes, we can do it. So we have done integrations of on-premise SAP with stuff which runs on Azure. So I think I talked about 2 examples. One was the vendor portal, and then we also have another example where the customer uses SAP for their ERP, and we do certain modules of it on Azure. I mean, they've done some modules of it on .NET, which run on Azure and integrates with the on-premise version. So that is definitely something that's possible. On-demand SAP, I'm not sure. Maybe you can shoot me an email with more details on this, and I can get back to you. All right. If there are no more questions, thank you, guys. Thank you for attending this session, and I hope you found it useful. And if you have some other questions that you come across later, just feel free to drop me a mail. Or if you are interested to learn more, please feel free. I'd be glad to engage with you and work with you in helping your organization transition applications onto Windows Azure. All right. Thank you once again, and bye-bye.